Me and Emily tried to film like 3 other times.
Yeah,
We just
coming
missed
during
the
class, not a good time.
It's
Not,
our site.
yeah, at your convenience, right? Lunchtime. But here we are. Question 12-3, number 5. So everybody take it up. Let's take a look at 12-3 and 5. Sounds like a few people had a question on it. Oh yeah. 12-3, number 5. I did. I literally did that one on the board. Literally. I don't know about first thing.
It was like, what, you did 3?
You did it on the board?
Examples?
Yeah. Go look at your notes. No, I didn't on the, like, everybody's looking at 12-3, number 5. It gives the vertices of RST. And then it tells you for number 5, find the equation of the lines containing perpendicular bisectors of RST, right? And so on this, okay, I didn't do the full problem on the board, but what you have is you have some sort of triangle, right? And the triangle, I mean, I could do the vertices. R is -4, right? -4, -3. Okay, so you drew a picture for starters. It's always with these ones. Then you go over, so there's R, then you go over to up 3, and there's S right there. And then -4, 5 for T. Okay, so -4 up 5, 1, 3, 4, 5. And so then there's T like that, R is T, and that's -4, 5. And then this is, what was this? I said 2, 3, and then -4 and -3, I believe?
Yep.
Okay. So then this is the one I explained how to do several parts of these, right? So you would review. When it says for the perpendicular bisectors, okay, how many perpendicular bisectors are there in a triangle? Yeah, 3, excellent. How many medians are there? 3. How many angle bisectors are there? 3. How many altitudes are there? 3. So they say find the equations of the perpendicular bisectors. How many equations are you going to have to find? 3. Yeah, you bet. Perpendicular means cuts at a 90. When you see things on a coordinate plane, you say cut at a 90, you instantly think perpendicular lines, which instantly tells you slopes are opposite reciprocals, you bet. And then, that's the perpendicular part. Bisector means cut in half, and so then on a coordinate plane, you instantly think midpoint. Absolutely. It would make the most logical sense. Midpoint, right? Cut in half. Therefore, it's in the middle, which would mean midpoint. So if you don't know midpoint, or you don't know how to find your slope, then you're done for until you learn how to do that, right? So how do I find perpendicular bisectors? You pick either one you want, right? So whatever, you have 3 to do. You say, okay, I want to find the perpendicular bisector right here. So it's going to go through that point. What do you need to write the equation of a line? You need a point and a slope. You bet. So do you know the point? Nope. Do you know the slope? Nope. But can you easily find the point? Do that. How do I find the point? Find the midpoint using the midpoint formula. Should you have the midpoint formula memorized by this point? Or have quick access to look it up real quick and get it done? Yeah, you bet. But you should have the midpoint. You've used it enough, or you've come across it enough, or, oh yeah, midpoint formula, let me review it enough. So you should have that one memorized. So what's the midpoint formula? Yeah. Yeah, so you just average of your x's, average of your y's, and you get out here where you get 1, 0, right? And that actually like, maybe 1, 0, is that right? No, -1, 0, I'm sorry, -1, 0, if I did my math correct here. Now, -1, 0, does that match my picture? No. Is it somewhat close actually to the picture? Yeah, you bet. Is the picture just a real rough sketch? Absolutely. So does this put you in the ballpark for what the midpoint is? Absolutely. We're okay with it not being spot on because I didn't put this on a coordinate plane with grids, right? We just sketched it. Now, if you came up with something like this, like -10, 17, I don't know, would that make any sense? No. right? So you think logically, you say, yeah, sure, that makes sense. There you go. So now you have a point. What do you need to have? You need to find a slope. You need to find the slope. So what is the slope? Well, the slope of this line, m equals what? How do I find the slope? Opposite reciprocal of a different slope. What's the other slope I would need to find? RS. Yeah, so you find the slope of RS, right? You say, okay, that is y2 minus y1 over 2 minus a negative 4. You absolutely know this slope of RS should be positive. We know that because it rises. There you go. So what do you get out? 6 over 6, and then you get a slope of 1. Does it possibly look reasonable that you have a slope of 1 there? Yeah, you know, if you came up with a slope that was negative, let's say, for RS, you'd instantly know you're wrong, because the slopes that are negative always go down that way. And then if you came up with a slope of, like, I don't know, 11, well, that wouldn't make much sense. If you had a slope of 11, that'd be a rise of 11, a run of 1. You know, that's way off. Or if you came up with, like, a pretty, like, you know, 1/4, run 1, you know, up 1 over 4, up 1 over 4. Yeah, no. So the slope of 1 makes sense for us, okay? So now that's for RS. That found RS. So then how do I find the slope of the line right here, up here? Opposite, and then reciprocal. What's the opposite of positive? Negative. What's the reciprocal of 1? 1. There you go. So now you have a point, and you have a slope. What do you plug into? There's 2 options to plug into. Point slope form or slope intercept. Yeah, you bet. Have I done several examples of those back in 12.2? Yeah. Right. So you could do that, or you could throw it up here. Y equals. I mean, I usually do y minus y1. That's just. And part of it is I have it memorized, and in other classes it's more beneficial to do it this route. That's why I end up trending that way. But you could do y equals mx plus b. It's your call, you know, for that. So 0 and then -1 x minus a -1. And all I'm doing is plugging in this point with a y value of 0 and x value of -1 right there. And then I'm plugging in a slope of -1 right there. And so then it's a nice negative x minus 1. And then you say, does negative x minus 1 make sense? And you'd say, okay, it's got a negative slope. Absolutely. It's a y-intercept of -1. Does that look like possibly close to a -1? Remember, sketch graph, so absolutely. And does it look like a slope of 1? Down 1, right 1, down 1, right 1. Yeah, looks pretty good. So then we'd say, yeah, you bet we got that one. Or at least we're going to be really close. So. Okay, now, how many of those do you have to do? 1 here, 1 here, 1 here. Nice thing about this one, what's real nice about this one? What?
It's a vertical line.
Yeah, if this is vertical, that tells you what's the other one have to be? Horizontal. So do you need to bother figuring out the slope of the vertical? No, because it's actually, what's the slope of the vertical? Undefined, you bet. So what does it tell you the slope of the horizontal is? 0. So the equation of this is whatever the y value is right here. What's the y value right there? 1. Yeah, you bet. 5 and -3 is 2. 2 divided by 2 is 1. Hello. You joining us? How'd you do? Sweet. Like pretty good? Does that mean you won?
Lost 1.
You won 2, lost 1? Wow. That's really good. So you played 3 matches already today?
Yeah.
Wow. That's awesome. 1, 2, lost 1. Congrats. That's good, guys. I mean, cool. Okay, so that one would be really nice because you just say, oh great, y is equal to 2. And there's no actually, like, you just do some mental work involved. When you have vertical and horizontal, it throws some of the stuff out the window because you end up with like undefined slopes, and it makes it a little bit more challenging to be plugging into point slope form when you have an undefined slope. You can't plug that in. So you got to recognize it's vertical and then make the horizontal note from there. Yeah, Nick.
Would that be y equals 1?
Or y equals 1, is that what we said? 5 over negative 3 is 2, and then divided by 2 is 1. So, yeah, so then that's an easy, or if you have a horizontal, then you have to go backwards and find this vertical, and then that would be x equals something. Okay? So that's how you find perpendicular bisectors again. And then if it's asked like number 4, it says find the medians, and we discussed how to find medians, right? Medians come from a point, they come from a vertex, and then they go to the other side and they hit in the middle. So you got to find the midpoint, then you already have a point, 2 points, and you need to find the slope of those. Okay? So that's what we do on that one. Then there's a request for number 6.
Yes.
Is that correct? Yeah, so that just draws scatter plot. Graph all those points, right? Within reason. Obviously, you shouldn't be doing tallies up to 150 or whatever they are, right? It shows you a little like graph how to do to make those tallies. You could also look in the book for a prime example on page 586 how to make a scatter plot with larger values. So you make your scatter plot, then what do? You pick how many points to write the equation of the line. Pick 2, and then find the slope. Will your answer be the exact same as the book's? Probably not. Now it's an even, so you probably don't have access to it. So your answer is probably going to be a little bit different because the book is going to use 2 points, and it's very likely that they won't use the 2 points you use, right? So when you do that, though, you make the best scatter plot you can within reason. I'm not saying hours long, but take a little bit of time to, okay, that looks reasonable. And after you do the giant scatter plot, right, it's like this and a little bit like that, and then it goes out and up like that. Once you get the scatter plot, right, like this, you have to analyze, there you go, you got all those dots, you got to analyze which 2 points am I going to use to write the equation of the line. Once you do that, you want to say, you know what, I'm not going to pick this and this because that looks like way off. Because it would be way off as long as your scatter plot is somewhat accurate. And if you pick those 2 points, does that dotted red line represent the blue dots at all? No. So you just have to pick 2 points. So is it arbitrary? No, it's educated. Okay, now as we get into like Algebra 2, pre-calc, and other statistics, then it's an exact science. We figure out a way to find exactly, and you actually don't use 2 points, you use the average of all your points, so you don't have to worry about that though. You just pick 2 points. So which 2 points? You choose, but choose with some, like an educated guess, right? Does that make sense? I mean, so I say you choose, well yeah, there's 2 points you don't want to choose, like that one and that one. Now if you choose this one and this one, is that going to be accurate? No. You choose this one and one way out there, is that going to be fairly accurate? Yeah, you bet. Now, if you have a random point, like way down, if your first point for some reason was randomly way down there, then that might prove a little bit challenging on using the first point there and these other ones, or another point over there. It might be a little bit off, but you can pick the first point that you graph, and then maybe the last point you graph is probably going to give you a decent accuracy to it, right? And you all should know how, if you did 12-2, how to find the equation of the line using 2 points, right? You have 2 points, what do? Find the slope, and then you plug into point slope form or to y equals mx plus b form. Again, your answer may be slightly different or, than what the book has, and that's okay. Or you may end up with some giant slope because you're using very large numbers there. So your slope may be some bizarre fraction for you, like 132 over, 90, 97. That seems crazy. Well, yeah, your numbers are very, very large numbers on that one for number 6. So you could end up with something with a kind of an expansive slope. Looks very different. You could put the slope in a decimal form is okay too. If you end up with a decimal, you could do that as well. So that's how you cover or do number 6 there. Okay. So let's cruise forward. We're going to make some headway. I think we discussed not grading today, right? I don't know. Or were we going to grade 12 dash? I think we're going to grade 12-3, weren't we? Okay, we're going to grade 12-3, and then go forward from there. What were we, and then tomorrow, what are we doing tomorrow? MCA tomorrow, right? Yes, without one lesson. Is assessment often will be studied up and prepared for the test in great detail. And it should, theoretically. So, mid-chapter assessment tomorrow. So let's go ahead and take a look then at, what do we have here? Grading. 12 point, we need to grade, not 12.4, what do we need to grade? 12.3? Nothing? Oh, wow, just need to keep procrastinating on it? On 12.3? Yeah, some of you. Okay, if you want to procrastinate on it, procrastinate away. We can grade it tomorrow. So. Okay, let's talk about 12-7, coordinates in space. So coordinates in space simply means that we are going to be adding a third variable, but it doesn't actually get that complicated. We add two formulas, but guess what? The formulas you add are actually going to be the same thing as the, although I don't, the two formulas. The formulas we are going to talk about are the same formulas that we've already discussed, except they're just adding a third component of it. So it actually doesn't add too much detail in the sense of this. So we're going to add like a three-dimensional space, or make it look three-dimensional. So what this is that you have, and no longer just a two-dimensional XY Z plane, I'm sorry, not an XY plane, but you're going to end up with an XY Z plane, okay? So in this, your axis will actually look something like this, and then something like that. Should have gone through a little better. So you now have, okay, this look like this. So now we are going to have where we label this as X, this as Y, and that as Z. Okay? So with this, then you're not going to have an ordered pair, you're going to have an ordered triple. So an ordered triple for this. So if we look at this, what we would look at this as is this would be, the Z is pretty easy to see, if you will, in terms of like positive, negative. So from the origin here, Z going up is positive, Z going down would be negative. Okay? Then when you look here at the Y is actually going to match, just like we've done with an XY plane. Meaning to the right is going to be positive, to the left is going to be negative. Okay? And then with the X value here, then we say that X going out this direction is going to be positive, the X going out that direction will be negative. Okay, so no longer an ordered pair, but rather an ordered triple. So if we were to do an ordered triple, the ordered triple is always going to be X, Y, and then Z. So it's in that order. And if we saw let's graph a point like, let's go 4, and -2, and then whatever, 5, let's say. Okay. So now we have 4, -2, and 5. If that is the case, then what we would do here is we would go with this. Okay, you start by going out 4 on the X, so we could label, 1, 2, 3, 4. You go out 4 on the X, and then you go -2 on the Y. Now, a -2 is something like that. So we're just going to come out 2. Now, if you have to graph anything, we're not going to get caught up in the weeds of exactly how it looks. Don't worry about like, oh no, and this is hard to like space out. It's just a general like out 4 in the positive, -2 for the Y, and maybe that was a little too far, So we would say, okay, maybe it's more like this, -2 like that. So then you come out 2 like that, and you've come out to this point. So you've gone out 4, you've gone over 2, negative, and then the question is, how do you represent up 5? Well, one way to do it is actually just to do like I'm doing here with a dotted, and then you go up 5. Now up 5 would be like 1, 2, 3, 4, 5, and so then you could just put, and then you put a dot out there. And so that helps us recognize that we went out to here, over to here, and then up to there. So something like that. If you were to do, I can do it in a blue pen here. Let's do another one. Let's say you had a coordinate, let's go a -3, and then a positive 6, and then negative, -4, let's say like that. So if we have a -3, 6, and then -4, we start at the origin, and then if it's a -3, you would go 1, 2, and 3. And then if it's a positive 6 on the x, 1, 2, 3, 4, 5, 6, you would come out, so you're like going out 3 in the negative direction, out 6 in the positive, and then which way do I go? -4, so we would go down approximately 1, 2, 3, 4, just down somewhere like that in space, and it would be a point down there. So you would go a -3, a positive 6, down 4, and you would end up down there. Okay? So then we can do things with those coordinate points, and the basics of this, like I said, you already have the equation, meaning, can you find the distance between those 2 points? Yes. Can you find the midpoint between those 2 points? Yes. All it is the distance formula, except you add a z component, and then it's the midpoint formula, except you add a z component as well. So we'll do that. We'll do the distance formula is going to be the exact same thing, except we're going to have 3 parts underneath the square root. And those 3 parts are going to be x's subtracted, y subtracted, and then z subtracted. So in this case, you could go 4 minus a -3 squared, and then -2 minus 6 squared, and then 5 minus a -4 squared, like that. Okay? And then you simplify from there. So that's it. It's just the distance formula. You just take the x's, the y's, and now the z's, and then you simplify from there. And so it takes a little bit more, just a slight amount more work, right? So we have 7, so what do we get there? 49 plus 64 plus 81, right? 5 and 4 and 81, and then you just keep going from there. And if they wanted simplest radical or decimal, you can do that with the calculator. So that's all there is to the distance formula. Add your z component. When you go for the midpoint, okay, so the midpoint, same thing, except now I'm not just finding an x and a y, I'm going to find an x, a y, and a z. And we know in the midpoint, it's just finding the averages of everything. And so you're going to add them all together. So you're going to take 4 and -3. You're going to say 4 plus a -3. And then you're going to say a -2 plus 6. Like that, and then you're going to say 5 plus a -4, like that, and then find the average of all those. So it would end up being, 1/2, and then 2, and 1/2 on that. So that would be your midpoint right there. Which again, if you were to actually look at that midpoint and say, does that seem to kind of match with what I have in between the green point and the blue point, you could say out a half, over 2, and then up a half. And my picture is, a little bit off, but the point I'm finding is somewhere right about in there. Sure, that could be my midpoint. It's close enough, for a sketch graph. So that's all that adding a third component does in this, is it allows you to have an x, y, z plane. Now the other thing that they will talk about is in a 3-dimensional space for this, they'll talk about, in a 2-dimensional space, we talked about a circle, okay? Anybody remember the circle equation? So in an xy plane, and you had a circle equation, okay, here's your circle, there's your center, and then the radius. Anybody remember what the circle equation was? something, something, and then something, right? So x and y and x minus, I don't know if you remember, h, y minus k, and your center was h comma k, and then your radius is just r. Okay, so that's the circle equation from chapter 9. Okay, now, when you have the center of a sphere, okay, sphere implies three-dimensional. Now, with the center of a sphere, it's the same equation, okay, except you're going to add a third component. So for the sphere equation, they're going to ask a question like, what is the center of the sphere? So in this case, you're going to see this equation like this. It's going to say x minus 2 squared plus y plus 7 squared plus z minus 4 squared is equal to, and then they're going to have some sort of value over here. Let's say 81. Pick a nice, perfect square for us. So they're going to say, what's the center of the sphere, and then what's the radius of the sphere? When it's talking about a sphere, it's three-dimensional. So our three-dimensional sphere, the center is going to have an x, y, and z component. The radius is still just a radius. It's not like the radius has two dimensions to it. It's just a singular distance, right? So in this case, the center of this sphere is going to be what? 2, -7, and then 4. And you'd have to remember from our work with circles in chapter 9 a little bit that a lot of people say -2, +7, and -4. But the formula is x, like I wrote over here, x minus the value. So this is x minus a +2, y minus a -7. And so that's where I get my center of the sphere from. Then my radius is not 81, right? That's right. Because the equation is this value squared, right? So whatever value is there has been squared. Therefore, my radius is not 81 because r squared is equal to 81. R is going to be equal to 9. We don't say plus or minus because radius will always be positive. So we just say 9 in that case. So you'll have to make a note of that. Then, going backwards, you will have to do one other thing, and that thing is this. If I can erase this, is fine. They will give you a center, and then they'll give you a radius, and you're going to write the equation. So they're going to give you, they're going to say, hey, here's your center. Let's say a -1/2, comma, 11, comma, 2, and then they're going to give you a radius is equal to the square root of 101. Make up a little bit unique value there. Okay? So you're going to be given the center, and then you're going to be given a radius, and they're going to say write the equation of a sphere. Again, it's not a circle. We know it's not because there's 3 parts to the center, which means it's three-dimensional. So all you're going to do is you're going to take this concept of this formula, and you're just going to plug in, and you're going to say, okay, I'm going to have this, plus this, plus this, plus, or not plus, I'm sorry, equals, and then something being squared. So we take a look, we say, okay, it's going to be x, matches to here, minus a -1/2, because the formula is minus, right? And then z is our third component, so z minus 2. Then with the radius, don't forget, don't leave it, if you have something like this, don't leave it as something being squared, because it's the radius being squared, you should simplify that, right? So when you rewrite the formula, you wouldn't want to leave this either. You would say x plus the half, y minus 11. Now the nice thing is you don't have to FOIL all this out. You can just leave it as that, just simplify it like that. And that would be your equation of the sphere. Okay? So there's like 4 parts, I guess, to this. One is a graphing component, like we just showed there. 2 was the distance formula, the midpoint formula. And then that's our second and third part. And then our fourth part is analyzing the equation of a sphere. And so you have a center, and you have a radius, and you go from there. Okay? So these ones hopefully won't be too difficult for finding some of this information maybe a little bit of reprieve from finding the equations of lines and things like that. All right, this will not be on the mid-chapter assessment, right? So this one won't be, when will this be due? On Tuesday. Yeah, so will not be on the mid-chapter assessment, so if you want to just hit pause on it, no problem. You know, don't have to worry about it, don't have to think about it. Take a look at 12:1 through 12:6 with the vectors and go from there. Okay? Utilize your time wisely. You only have 12 minutes, but utilize that time. Utilize the time wisely.